Hello and welcome to the Sleepy Astronomer. This is the place where we gently wander through the cosmos, one quiet question at a time, designed to help you relax, wind down, and maybe even learn a thing or two on your way to sleep. If you joined me recently for Carl Sagan's story, that journey from a curious Brooklyn boy to humanity's cosmic messenger, you'll remember how one person's questions transformed into a gift for all of us. How a rebel who challenged every assumption became the gentle voice that helped millions understand their place among the stars. Tonight, we follow that vision to its furthest reaches, to a photograph taken from the edge of our solar system that reveals our world as something both humbling and precious. We're not travelling outward to distant stars or galaxies, but turning our gaze back toward home, back to Earth as it truly is, a pale blue dot suspended in the cosmic dark, carrying everything and everyone you've ever known or loved. It's a perspective that has moved astronauts to tears, inspired poets and philosophers, and fundamentally changed how we understand our place in the universe. It's the vision that Carl Sagan, with his characteristic blend of scientific precision and poetic wonder, helped us finally see clearly. Tonight, we'll explore what happens when you step back far enough to see our entire world as it really is. Not the center of creation, but a small, beautiful, precious oasis floating in the vast emptiness of space. Now, before we begin this cosmic journey, if this is your first time here, welcome to our little corner of the universe. And if you're returning, thank you for travelling with me again across the cosmic distances. If these gentle journeys through space and time help you unwind, I'd be ever so grateful if you'd tap that like button and consider subscribing. It's the simplest way to ensure we can continue exploring the universe together, one sleepy night at a time. Our journey begins with the first humans who saw Earth from a distance, astronauts who looked back from the moon and found themselves unexpectedly moved by what they witnessed. Something about seeing our world floating in the void changed them in ways they hadn't anticipated, a transformation that would later be recognized as the overview effect. From there, we'll zoom out even further, tracing Earth's place in the vast cosmic hierarchy, from our local neighborhood to the edge of the observable universe. And somewhere along that journey, we'll pause at a moment in 1990 when a spacecraft, already beyond the orbit of Neptune, turned its camera back toward home and captured something extraordinary. Our entire world reduced to a single pixel of light, barely visible against the cosmic dark. That photograph sparked one of Carl Sagan's most beautiful meditations, a reflection on what it means to live on this small stage, this mote of dust suspended in a sunbeam, and it raises a question that still haunts us. What makes this pale blue dot so special? Not because it sits at the center of everything, but perhaps because it represents something extraordinarily rare. A world where the universe has learned to look back at itself with wonder. So, settle in, take a deep breath, and prepare to see your home with new eyes. Let's drift together into the vast perspective that comes from viewing Earth not from its surface, but from the cosmic distances that reveal its true nature as a small, beautiful, irreplaceable dot of life in an otherwise empty universe. Close your eyes if you'd like, and imagine that we're slowly pulling back from Earth's surface, rising higher and higher until our entire planet comes into view, blue and white and achingly beautiful against the black backdrop of space. This is where our journey begins tonight, with the most beautiful sight in the known universe, our home, seen from afar. To understand the profound impact of seeing Earth from space, we need to go back to December 1968. when 3 human beings became the first to witness something no one in history had ever seen before: Earth rising over the lunar horizon. Apollo 8 astronauts. Frank Borman, Jim Lovell and William Anders had travelled 250,000 miles from home, further than any humans had ever ventured. Their mission was to orbit the Moon and return safely, a crucial test flight preparing for the eventual lunar landing. But what they found looking back at Earth would prove just as significant as anything they discovered about the Moon. As their spacecraft emerged from behind the lunar far side, William Anders looked out his window and saw something that stopped him in his tracks. There, rising above the Moon's stark, crater-scarred horizon, was Earth, a brilliant blue and white marble suspended in the black void of space. "Oh my God," Anders exclaimed. "Look at that picture over there. There's the Earth coming up. Wow, that's pretty." The photograph he quickly snapped, now famous as Earthrise, became one of the most influential images in human history. But it wasn't just the photograph that mattered. It was what the astronauts felt when they saw it. For the first time in human history, people were seeing Earth not as an endless landscape stretching to the horizon in all directions, but as it truly is, a finite world, isolated in space, with no borders visible from that distance, no signs of the conflicts and divisions that seem so important from the surface. Frank Borman later described the experience. "We came all this way to explore the Moon, and the most important thing is that we discovered the Earth." This wasn't just poetic license. There was something about seeing Earth from that distance that fundamentally changed how these astronauts understood their home planet. The Moon, which had seemed so mysterious and significant from Earth, suddenly seemed barren and lifeless compared to the vibrant living world they had left behind. From lunar distance, Earth appeared not as the solid, permanent foundation of human existence, but as something precious and fragile. You could block it out with your thumb. All of human history, every person who had ever lived, every story ever told, every war ever fought, every love ever felt, all of it was contained on that small blue sphere floating in the cosmic dark. But the Apollo astronauts weren't the first to experience this shift in perspective. Earlier space missions had already begun to reveal Earth's true nature, though from much closer distances. In 1961, Soviet cosmonaut Yuri Gagarin became the first human to orbit Earth. From his vantage point just 200 miles above the surface, he could see the curve of the horizon, the thin blue line of the atmosphere, and the way Earth appeared to hang in space without any visible support. "I see Earth," he radioed back. "It is so beautiful." But Gagarin's view was still relatively close. He could make out continents, weather patterns, the day-night Terminator moving across Earth's surface. The Apollo 8 crew was the first to see Earth truly small, truly distant, truly isolated in the vastness of space. American astronauts in the Mercury and Gemini programs had similar experiences to Gagarin's. They described the overwhelming beauty of Earth from orbital altitude, but also something more, a sense of unity and fragility that was difficult to put into words. Ed White, during the first American spacewalk in 1965, was so moved by the view of Earth that mission controllers had to repeatedly ask him to return to the spacecraft. "It's the most beautiful sight," he said, floating free in space with Earth rotating slowly beneath him. These early space travelers often struggled to find adequate words for what they were experiencing. The view of Earth from space wasn't just visually stunning, it was emotionally and spiritually transformative in ways that no amount of training had prepared them for. Part of this transformation came from seeing Earth's atmosphere for the first time as it really is, an incredibly thin shell of gas clinging to the planet's surface. From space, the atmosphere that seems so vast and inexhaustible from ground level appears as a delicate blue line, thinner than the skin of an apple relative to the apple itself. Russell Schweickart, who flew on Apollo 9, described it this way: "You look down there, and you can't imagine how many borders and boundaries you cross again and again and again, and you don't even see them. From where you see it, the thing is a whole, and it's so beautiful." This absence of visible borders became a recurring theme in astronaut accounts. The political divisions that dominate news and history simply don't exist from space. There are no lines drawn across the continents, no walls visible from orbital altitude, no indication of the human conflicts that seem so important from the surface. Instead, there's just Earth, one world, one system, one interconnected biosphere, where weather patterns, ocean currents, and atmospheric circulation ignore human political boundaries completely. The same storm system might bring rain to multiple countries. The same ocean connects distant continents. The same atmosphere is shared by everyone, regardless of nationality, religion, or ideology. But perhaps most profound was the realization of Earth's apparent isolation. From space, Earth doesn't seem to be part of a larger neighborhood of worlds. The moon is visible, but it's clearly lifeless, airless, barren. The other planets aren't visible to the naked eye. The stars, though beautiful, appear as distant points of light that emphasize rather than diminish Earth's cosmic solitude. This isolation isn't threatening from space. It's precious. Earth becomes not just home, but the only island of life and warmth and colour in an otherwise cold and empty cosmos. The responsibility for caring for this world becomes not just environmental or political, but cosmic. Astronauts frequently returned from space missions with a changed perspective on human conflicts and priorities. Edgar Mitchell, who walked on the moon during Apollo 14, spent the rest of his life exploring consciousness and human potential. He said the view of Earth from space gave him an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. This wasn't unique to Mitchell. Many astronauts became environmental advocates, peace activists, or dedicated their lives to education and international cooperation. Something about seeing Earth from the cosmic perspective made human divisions seem petty and human cooperation seem essential. The psychological impact was so consistent and so profound that researchers eventually gave it a name, the overview effect. But we'll explore that more deeply in a later chapter. For now, let's stay with those first remarkable moments when human beings first saw their home planet as it truly is. The Apollo 8 mission took place during one of the most turbulent years in modern American history. The year 1968 had seen the assassinations of Martin Luther King Jr. and Robert Kennedy, violent protests against the Vietnam War, and social upheaval around the world. When the Apollo 8 crew read from the Book of Genesis while orbiting the moon on Christmas Eve, "In the beginning, God created the heaven and the earth," their words were broadcast to what was then the largest audience in television history. But it wasn't just their words that moved people, it was the context. Three human beings, farther from home than anyone had ever been, looking back at Earth and seeing not a collection of warring nations, but a single, beautiful, fragile world floating in the cosmic dark. The timing wasn't accidental. NASA had rushed the Apollo 8 mission, originally planned as an Earth orbital test flight, specifically to orbit the moon by the end of 1968. The space race with the Soviet Union provided the immediate motivation, but the mission's impact went far beyond national competition. At a time when human divisions seemed overwhelming, when the problems facing humanity seemed intractable, suddenly there was this new perspective, a view of Earth that made human unity not just possible, but obvious. We weren't Americans and Soviets or developed and developing nations or different races and religions. We were all Earthlings, all passengers on the same cosmic vessel, all sharing the same thin shell of air and water and life. The technology that made this perspective possible was remarkable in itself. The Saturn V rocket that carried Apollo 8 to the moon was one of the most complex machines ever built, standing 363 feet tall and weighing 6.2 million pounds when fully fueled. Yet it was built for a purpose that went beyond its impressive specifications. It was built to expand human consciousness, to give our species to see itself from a cosmic perspective. And in a sense, that's exactly what it accomplished. The images and experiences from Apollo 8 didn't just advance space exploration, they changed how humanity thinks about itself. Environmental movements gained new momentum when people could see Earth as a single, integrated system. International cooperation became easier to imagine when national borders disappeared from view. But there's also something beautifully humble about these first glimpses of Earth from space. These astronauts, who had trained for years to be explorers and pioneers, found themselves most moved not by their own achievements but by the sight of home. They had travelled further than any humans in history, and what they discovered was a new appreciation for the world they had left behind. Perhaps that's the most profound aspect of seeing Earth from space. It doesn't diminish our planet's importance, but enhances it. Earth becomes not just one planet among many, but the precious, irreplaceable, beautiful world that contains everything we've ever known or loved. As we continue our cosmic journey tonight, we'll explore what it means to place Earth in the larger context of the universe, but we'll carry with us this fundamental insight from those first space travelers, that sometimes you have to go very far away to truly appreciate how extraordinary it is to be home. Now that we've experienced the profound shift in perspective that comes from seeing Earth from space, let's take an even more dramatic step back. Let's explore exactly where our pale blue dot sits in the vast hierarchy of cosmic structures, from our local neighbourhood all the way out to the edge of the observable universe. Carl Sagan loved to contemplate this question, where we live in the cosmos. Understanding our cosmic address is like zooming out from a detailed street map to see increasingly larger views. Your neighbourhood, your city, your country, your continent, your planet. But in this case, we're zooming out through scales of size and distance that quickly become almost impossible to truly comprehend. Let's start with something familiar and work our way outward. You're currently listening to this while somewhere on Earth's surface. Earth itself has a diameter of about 12,800 kilometres, or roughly 8,000 miles. If you could drive around Earth's equator at highway speeds without stopping, it would take you about 4 days. That's pretty big from a human perspective, but let's zoom out just a little. The Moon, our closest celestial neighbour, orbits at an average distance of about 384,000 kilometres from Earth. If you could drive to the Moon at highway speeds, ignoring the minor issues of vacuum, radiation, and the lack of roads in space, it would take you about 4 months of continuous driving. Already we're dealing with distances that dwarf human experience, but we're still in our immediate cosmic neighbourhood. Let's continue outward. The Sun, the gravitational centre of our solar system, sits at an average distance of about 150 million kilometres from Earth. Astronomers call this distance one astronomical unit, or AU, and it becomes a useful measuring stick for solar system distances. At our hypothetical highway speeds, it would take you about a century of continuous driving to reach the Sun, assuming you could somehow avoid being vaporized long before you arrived. But the Sun is just the beginning of our solar system. The most distant planet, Neptune, orbits at about 30 astronomical units from the Sun. Pluto, though no longer classified as a planet, reaches about 40 astronomical units at its farthest point. But even these distant worlds are still in the Sun's immediate neighbourhood. The true edge of our solar system, the region where the Sun's influence finally gives way to interstellar space, lies much farther out. The Kuiper Belt, home to Pluto and thousands of other icy objects, extends to about 50 astronomical units. Beyond that is the scattered disk, and beyond that, the hypothetical Oort cloud, a spherical shell of comets that may extend as far as 100,000 astronomical units from the Sun. To put this in perspective, if Earth's orbit around the Sun were the size of a quarter, the Oort cloud would extend about as far as a football field in every direction. Our entire solar system, vast as it seems from an earthly perspective, is really just a tiny bubble of the Sun's gravitational influence in the much larger ocean of interstellar space. And speaking of interstellar space, let's zoom out to the next level of our cosmic address. The nearest star to our Sun is Proxima Centauri, part of the Alpha Centauri system, at a distance of about 4.3 light-years. Now, we're not talking about driving times anymore, because even light, the fastest thing in the universe, takes 4.3 years to travel from that star to us. If our solar system were the size of a quarter, the nearest star would be about 11 miles away. Space, as Douglas Adams observed, is big. Really big. You may think it's a long way down the road to the chemist, but that's just peanuts to space. But Proxima Centauri is just our nearest neighbour in what astronomers call the local interstellar cloud, a region of slightly denser gas and dust that our solar system is currently passing through. This cloud is part of the local bubble, a region carved out by ancient supernova explosions. Zooming out further, our Sun is located in what's called the Orion Arm, a minor spiral arm of the Milky Way galaxy, nestled between two major arms. We're about 26,000 light-years from the galactic centre, roughly halfway out to the galaxy's edge. If the galaxy were a giant city, we'd be living in the suburbs, not downtown. The Milky Way itself is enormous, about 100,000 light-years across and containing somewhere between 100 and 400 billion stars. If you could count one star per second, it would take you thousands of years just to count our galaxy's stellar population, and each of those stars is like our Sun, potentially with its own family of planets. But the Milky Way, vast as it is just one galaxy among many. Our nearest large galactic neighbour is the Andromeda Galaxy, located about 2.5 million light-years away. The Milky Way and Andromeda, along with about 50 smaller galaxies, make up what astronomers call the local group. The local group itself is part of an even larger structure called the Virgo supercluster, which contains thousands of galaxies spread across a region about 110 million light-years in diameter. And the Virgo supercluster is just one of many such superclusters scattered throughout the observable universe. Recent observations have revealed even larger structures. The Virgo supercluster turns out to be part of an enormous structure called Laniakea, Hawaiian for immense heaven, which contains about 100,000 galaxies and spans over 500 million light-years. And Laniakea itself is just one supercluster complex among many in the cosmic web of dark matter and ordinary matter that fills the universe. At the largest scales we can observe, the universe appears to be structured like a vast foam, with dense filaments of galaxies surrounding enormous voids containing very little matter. These structures span billions of light years and represent the largest patterns in the known universe. So where do we live in this vast cosmos? We're on planet Earth in the solar system, nestled within the local interstellar cloud, part of the Orion arm of the Milky Way galaxy, which belongs to the local group of galaxies within the Virgo supercluster, itself part of the Laniakea supercluster complex. One small strand in the cosmic web that stretches across the observable universe. And all of this exists within the observable universe, which extends about 46 billion light-years in every direction from Earth, not because the universe is that old, but because space itself has been expanding since the Big Bang, stretching the light from the most distant objects we can see. Now, here's where things get really mind-bending. We don't know if the observable universe represents the entire universe, or just the part we can see. The actual universe might be much larger, possibly infinite, extending far beyond the horizon of our observations. But even sticking to what we can observe, the numbers become almost meaningless. The observable universe contains an estimated 2 trillion galaxies, each containing billions or hundreds of billions of stars. There are more stars in the universe than there are grains of sand on all the beaches on Earth. And in this vast cosmic hierarchy, Earth is, well, it's almost invisible. If you could somehow view the entire observable universe at once, Earth wouldn't even register as a pixel. Our entire solar system would be invisibly small. Our galaxy would be just one faint smudge among trillions of others. This might seem humbling to the point of being depressing. In the cosmic scheme of things, we seem utterly insignificant, temporary, forgettable. Carl Sagan captured this feeling when he wrote about the cosmic perspective that astronomy inevitably brings. Our planet is a lonely speck in the great enveloping cosmic dark. But there's another way to look at it. Yes, we're small in terms of size and brief in terms of cosmic time, but we're also, as far as we know, extraordinarily rare. In all those trillions of galaxies and countless billions of stars, we haven't yet found definitive evidence of life anywhere else, let alone intelligent life capable of contemplating the universe as we're doing right now. This makes Earth not insignificant, but precious beyond measure. We're not just a pale blue dot. We're the pale blue dot, possibly the only place in the observable universe where matter has organized itself into patterns complex enough to wonder about its own existence. Think about that for a moment. The universe spent nearly 14 billion years evolving from a hot, dense state into the current cosmic web of galaxies and voids. Stars formed and died, creating and dispersing the elements necessary for rocky planets and complex chemistry. On at least one world, our world, conditions came together in just the right way for life to emerge, evolve, and eventually develop consciousness. And now, through us, the universe has become aware of itself. The atoms that make up your brain were forged in stellar cores and scattered by supernova explosions. You are literally made of material that has travelled across vast distances and cosmic time to come together in the pattern that is you. And somehow, this collection of star stuff has become organised in such a way that it can contemplate the very cosmos from which it came. This is perhaps the most remarkable thing about our cosmic address, not where we are in space, but what we represent in the universe's ongoing evolution. We are the universe becoming conscious, matter, organising itself into patterns that can experience wonder, beauty, love, and understanding. From this perspective, our small size in cosmic terms doesn't diminish our significance. It enhances it. We're not just occupying space in the universe. We're participating in the universe's attempt to understand itself. Every time you look up at the night sky and feel a sense of wonder, You're participating in a cosmic awakening that has been billions of years in the making. Our cosmic address, then, isn't just a description of our location in space. It's a description of our role in the universe's ongoing story. We live on a small planet orbiting an ordinary star in the outer reaches of a typical galaxy, but we're also the place where hydrogen atoms evolved into beings capable of mapping their cosmic neighborhood, of measuring distances to other galaxies, of contemplating the size and age and structure of the universe itself. And perhaps most remarkably, we're the place where the universe has learned to feel humility, wonder, and awe at its own vastness. When you contemplate the cosmic scales we've explored tonight, you're not just learning about astronomy, you're participating in one of the universe's most extraordinary achievements, the development of cosmic consciousness. As we continue our journey tonight, we'll explore how this cosmic perspective affects the human beings who experience it most directly. The astronauts who have seen Earth from space, but for now, rest in the knowledge that while you may live on a small world in a vast universe, you are also one of the ways the universe has learned to appreciate its own magnificent complexity. Your cosmic address might seem humble, but your cosmic significance is beyond measure. You are, quite literally, the universe becoming aware of itself, one sleepy moment at a time. There's a profound transformation that happens to many people when they see Earth from space for the first time. It's not just intellectual, though understanding Earth's place in the cosmos is certainly part of it. It's not just emotional, though the beauty of our planet seen against the cosmic backdrop is often overwhelming. It's something deeper, a fundamental shift in consciousness that often changes how people see themselves, humanity, and their place in the universe for the rest of their lives. This transformation is so consistent, so well documented, and so profound that researchers have given it a name: the overview effect. The term was coined by author Frank White, who interviewed dozens of astronauts and cosmonauts to understand the psychological impact of seeing Earth from space. What he discovered was that this experience triggers a cognitive shift that goes far beyond what you might expect from simply seeing a beautiful view. Let's explore what this transformation involves and why it happens with such remarkable consistency. The overview effect typically begins with the simple act of looking at Earth from space, but it quickly becomes something much more complex. Astronauts describe an immediate sense of Earth's beauty: the vivid blue oceans, the swirling white clouds, the thin line of the atmosphere glowing against the black of space. But within moments, this aesthetic appreciation transforms into something deeper. What comes next is a recognition of unity that feels almost overwhelming. From space, Earth appears as a single, integrated system. There are no political boundaries visible, no walls or fences dividing nations. The atmosphere doesn't stop at borders. Ocean currents flow between continents. Weather systems ignore human political divisions completely. What becomes inescapably obvious is that Earth is one world, one interconnected biosphere, where everything is related to everything else. Edgar Mitchell, the sixth person to walk on the moon, described it this way: you develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. This sense of unity naturally shifts how astronauts think about human conflicts and divisions. The wars, territorial disputes, ethnic tensions, and ideological battles that dominate news and politics suddenly seem petty when viewed from the cosmic perspective. Not unimportant, the suffering they cause is certainly real, but somehow smaller, more manageable, less fundamental than they appeared from ground level. Russian cosmonaut Alexei Leonov, who was the first person to walk in space, put it simply: the Earth was small, light blue, and so touchingly alone, our home that must be defended like a holy relic. Notice that word, alone. From space, it becomes viscerally clear that Earth is humanity's only home. There's no backup planet, no escape route, no other world where human life could survive without extraordinary technological intervention. The moon is lifeless. Mars is barren and hostile. The other planets are even more inhospitable. This aloneness isn't frightening from the space perspective. It's precious. Earth becomes not just home, but the only home, deserving of protection and care, in the same way you might protect something irreplaceable and beautiful that you love. Many astronauts also report feeling a deep connection not just to Earth, but to the cosmos as a whole. They describe feeling part of something much larger than themselves, part of an unfolding cosmic story that puts their individual lives and human history in a broader context. This isn't necessarily religious, though some astronauts do describe it in religious terms. It's more of a recognition that consciousness, life, and intelligence are remarkable phenomena in the universe, and that humans have a responsibility as conscious beings to appreciate and protect the conditions that make such consciousness possible. Perhaps most remarkably, the overview effect seems to be universal across cultures, political systems, and personal backgrounds. Soviet cosmonauts reported the same basic experience as American astronauts. Military test pilots had the same response as civilian scientists. Religious believers and atheists, conservatives and liberals, introverts and extroverts, all seem to undergo similar transformations when seeing Earth from space. This universality suggests that the overview effect isn't a product of particular cultural conditioning or individual psychology, but something more fundamental about human consciousness when it encounters the cosmic perspective. The sheer beauty of Earth from space certainly plays a role. There's something about seeing our world floating in the void that triggers a protective instinct. The planet appears fragile, precious, in need of care. But it's more than aesthetics. The physical reality of Earth's interconnectedness becomes impossible to ignore. The atmosphere is one continuous envelope. The oceans are all connected. Weather patterns, ocean currents, and ecological systems operate as a single planetary system, completely indifferent to the borders we've drawn on our maps. The overview effect has had practical consequences beyond individual transformation. Many astronauts have become environmental advocates after their space experiences. Others have dedicated themselves to education, international cooperation, or conflict resolution. The experience of seeing Earth as one world often translates into a lifelong commitment to treating it that way. Interestingly, you don't have to go to space to experience something like the overview effect, at least partially. High-altitude flights can provide a glimpse of Earth's curvature and the thinness of the atmosphere. Images from space can trigger emotional responses similar to what astronauts describe, though typically less intense. Even imagining the view from space, as we're doing tonight, can provide some of the psychological benefits of the cosmic perspective. The Earthrise photograph from Apollo 8 had such profound cultural impact precisely because it allowed millions of people to see what astronauts had been describing: Earth as a beautiful, isolated, precious world floating in the cosmic dark. The image triggered a collective version of the overview effect, contributing to environmental movements and changing how humans thought about their relationship to their home planet. Carl Sagan never had the opportunity to see Earth from space himself. He remained earthbound throughout his life. Yet through the power of scientific understanding and poetic imagination, He captured the essence of the overview effect perhaps more perfectly than anyone who had actually made the journey. His meditation on the pale blue dot photograph, which we'll explore soon, distills the cosmic perspective into words that help us see what astronauts saw, feel what they felt, understand what they understood. This is part of what made Sagan so remarkable. He didn't need to physically leave Earth to achieve the perspective that transforms astronauts. Through careful study of planetary science, through contemplating the vastness of space and time, through the disciplined application of his imagination to scientific facts, he developed a cosmic consciousness as profound as any space traveller's. And then, with his gift for language, he shared that perspective with millions of people who would never leave Earth's surface. Astronauts who spend longer periods in space often report deeper and more lasting transformations. Those aboard the International Space Station, orbiting Earth every 90 minutes and watching the planet turn below them, day after day, describe becoming intimately familiar with Earth's patterns, the way morning light creeps across continents, how weather systems develop and move, the rhythm of seasons changing across different latitudes. These long-duration astronauts often develop what they describe as a planetary consciousness, a sense of thinking about Earth and humanity as integrated systems, rather than collections of separate parts. They start to see connections between events in different parts of the world, to understand how local actions have global consequences, to appreciate the delicate balance of systems that keep Earth habitable. The overview effect also seems to persist long after astronauts return to Earth. Follow-up studies have shown that the psychological changes often last for decades, influencing career choices, personal relationships, and worldview throughout the rest of their lives. This persistence suggests that the overview effect represents a genuine expansion of consciousness, rather than just a temporary emotional response to a beautiful view. Some astronauts describe it as if they have seen their hometown from a new angle and suddenly understood its layout and relationships in a way that had never been clear from street level. But instead of a hometown, they've seen their home planet, and instead of street-level confusion, they've transcended the limited perspective that comes from being bound to Earth's surface. The overview effect reminds us that perspective matters enormously in how we understand ourselves and our place in the world. The same Earth that appears divided and conflicted from the surface appears unified and precious from space. The same human problems that seem intractable from within our daily lives can appear more solvable when viewed from a broader context. This doesn't mean that the space perspective is more true than the earthbound perspective. Both are valid ways of experiencing reality, but it does suggest that consciously expanding our perspective, temporarily stepping back from our immediate concerns to see the bigger picture, can be a powerful tool for problem solving, stress reduction, and personal growth. As we continue our journey tonight, we'll explore one of the most famous expressions of the cosmic perspective ever written, Carl Sagan's meditation on the pale blue dot photograph. But for now, rest in the knowledge that the transformation experienced by astronauts is available to all of us, at least partially, through the simple act of expanding our perspective and remembering that we're all passengers together on this beautiful, fragile, irreplaceable world floating in the cosmic dark. The overview effect reminds us that sometimes the most profound insights come not from looking more closely at something, but from stepping back far enough to see it clearly for the first time. And perhaps that's exactly what we need more of in our world. Not more detailed analysis of our differences and divisions, but more opportunities to step back and see the bigger picture of our shared humanity on our shared planet. On February 14th, 1990, Valentine's Day, the Voyager 1 spacecraft, then about 3.7 billion miles from Earth, turned its camera back toward the inner solar system and took a series of photographs that would fundamentally change how humanity sees itself in the cosmos. The spacecraft was already well beyond the orbit of Neptune, hurtling toward interstellar space at 38,000 miles per hour. Its primary mission to explore Jupiter and Saturn had been completed years earlier. The cameras were essentially done, their job finished. But Carl Sagan had an idea that many at NASA considered, at best, a waste of precious resources. "Turn the cameras around," he urged. "Take one last picture of Earth before Voyager left the solar system forever." The resistance was immediate and practical. The cameras had already done their work. Voyager's power was limited, its remaining energy needed for the long journey ahead. Engineers worried about the risk of pointing cameras back toward the sun. Even from this distance, scattered sunlight could damage the optics. And besides, what was the point? Earth would be barely visible. Just a tiny speck among many. What could we possibly learn from such an image that we didn't already know? But Sagan persisted with his characteristic gentle stubbornness. This wasn't about new scientific data, he explained. It was about perspective. It was about seeing ourselves as we truly are, a small world in a vast cosmos. After years of advocacy, NASA finally agreed to what became known as the Solar System Family Portrait, a series of images that would capture the Sun and planets from the edge of our cosmic neighborhood. Most of the resulting images showed exactly what you'd expect from such a vast distance, a few bright dots representing the outer planets against the black backdrop of space. But one photograph in the series would become one of the most important images in human history, though at first glance it appeared to show almost nothing at all. The image was grainy and streaked with rays of sunlight scattered by Voyager's camera optics, and there, suspended in one of those sunbeams, was a tiny point of light barely visible against the cosmic dark. The science team almost missed it entirely. Earth was so faint it was nearly lost in the electronic noise of the camera. They had to search through the data carefully to find our world at all. It was Earth, every human being who had ever lived, every story ever told, every civilization ever built, reduced to what Carl Sagan would immortally describe as a pale blue dot. When Sagan saw this photograph, he was moved to write one of the most profound meditations on human existence and our place in the universe ever composed. His words, delivered in his characteristically gentle but profound style, became known simply as the Pale Blue Dot speech. Let's hear them now, in full, without interruption. From this distant vantage point, the Earth may not seem of any particular interest. But for us it's different. Consider again that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Let's pause here for a moment and really absorb what Sagan is asking us to consider. Every person you've ever met, every historical figure you've ever read about, every ancestor who contributed to your existence, every descendant who might carry forward your legacy, all of them have lived their entire lives on that tiny speck of light, barely visible in a photograph taken from the edge of our solar system. Alexander the Great conquered his known world on that dot. Shakespeare wrote his plays on that dot. The pyramids were built on that dot. The Beatles recorded their songs on that dot. Your parents fell in love on that dot. You're listening to this right now on that dot. And from Voyager's perspective, all of human history, all of human achievement, all of human struggle and triumph is contained within a pixel, so small you can barely make it out against the darkness. Sagan continued, "The Earth is a very small stage in a vast cosmic arena. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner, how frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Think of the rivers of blood spilled by all those generals and emperors so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. This perspective is both humbling and liberating. It reveals how small our individual concerns are in the cosmic context. The project deadline that's keeping you awake, the argument you had with a friend, the political issue that seems so urgent. All of these exist on a scale that doesn't even register from cosmic distances. Yet it's also strangely freeing. The things that seem overwhelming from up close often become more manageable when viewed from a distance. The problems that divide us as humans often seem less important than the simple fact that we're all sharing this tiny world together." Sagan's reflection continues. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. This loneliness isn't meant to depress us. It's meant to motivate us. If Earth is the only place in the known universe where life has taken hold, where consciousness has evolved, where beauty and love and art and science exist, then Earth becomes not just our home but our responsibility. We're not just living on this planet. We're its custodians, perhaps the only conscious beings in the entire cosmos, capable of appreciating and protecting the conditions that make life possible. In our obscurity, in all this vastness, Sagan wrote, there's no hint that help will come from elsewhere to save us from ourselves. This might sound lonely or frightening, but Sagan meant it as empowering. We can't look to the stars for rescue from our problems. We have to solve them ourselves. But we also can't pass our problems on to other worlds. Earth is where we live, where our children will live, where our species' entire future will unfold. This makes taking care of our world not just environmentally important, but cosmically essential. Despite our apparent insignificance in the cosmic scale, we've accomplished something extraordinary. We've become the part of the universe that can step outside itself and gain perspective on the whole. The atoms that make up your brain were forged in stellar cores billions of years ago, and now they're organized in such a way that they can contemplate the very cosmos from which they came. In all the vastness of space and time, in all the billions of galaxies and trillions of stars, as far as we know, only on our tiny pale blue dot has matter organized itself into patterns complex enough to understand its own place in the universe. We're not cosmic accidents, but cosmic achievements. We're not just observers of the universe, we're the universe observing itself. Every time you look up at the night sky and feel wonder, you're participating in the universe, becoming conscious of its own beauty and complexity. Sagan concluded his meditation with words that have become a touchstone for our time. The Earth is the only world known so far to harbour life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the pale blue dot, the only home we've ever known. The photograph in Sagan's meditation arrived at a crucial moment. The Cold War was ending. Environmental awareness was growing. For the first time, humans were beginning to think of themselves as a global species facing planetary-scale challenges. And suddenly, here was an image that made those challenges impossible to ignore. Not as problems facing particular nations or regions, but as challenges facing the only known conscious inhabitants of the only known living world in the universe. The response was remarkable. Letters poured into Sagan describing how the image and his words had changed people's perspectives. Teachers reported using the photograph to help students understand environmental responsibility. Politicians cited it in debates about international cooperation. Artists and poets found in it a new language for describing our relationship to our home world. The photograph itself has become an icon of the space age, reproduced countless times in books, documentaries, and websites. But its power comes not from its technical quality. It's actually a rather poor photograph by most standards, but from what it represents. The first time in human history that we could see our entire world as it truly is, a small part of something much larger. In many ways, the pale blue dot image is the visual culmination of the process that began with the first photographs of Earth from space. Those earlier images showed Earth as beautiful and unified when seen from lunar distance. The pale blue dot revealed Earth as small and precious when seen from interplanetary distance, but the real power comes from the combination of the visual and the verbal, Sagan's words giving meaning and context to what might otherwise be just another space photograph. This perspective doesn't solve the practical problems facing humanity, but it provides a framework for thinking about them. Climate change becomes not just an environmental issue, but a challenge to the only known living world in the universe. Nuclear weapons become not just a political issue, but a threat to the only known conscious beings in the cosmos. Poverty and inequality become not just social issues, but problems facing our fellow passengers on spaceship Earth. And on a personal level, when you're dealing with stress, anxiety, or difficult life circumstances, sometimes it helps to zoom out and remember that you're part of something much larger and more beautiful than your immediate problems. You're not just struggling with work or relationships or health issues. You're participating in the remarkable cosmic story of matter becoming conscious, of the universe waking up to its own existence. Many current astronauts, planetary scientists, and space engineers cite Sagan's words as part of what motivated them to pursue careers in space exploration. The idea of expanding human perspective by literally expanding our presence in the cosmos has become a driving force behind missions to Mars, searches for life on other worlds, and projects to detect planets around other stars. But you don't need to become an astronaut or planetary scientist to benefit from this perspective. You can cultivate it in your daily life by occasionally stepping back from immediate concerns to consider the broader context of your existence. You're not just living your individual life, you're participating in the ongoing story of life on Earth, consciousness in the universe, and the cosmic evolution that has been unfolding for billions of years. Sometimes, when the news seems overwhelming or personal problems seem insurmountable, it helps to remember that you're riding on a small blue world that's spinning through space at thousands of miles per hour, orbiting a star that's racing through the galaxy at hundreds of thousands of miles per hour, in a galaxy that's moving through the universe at millions of miles per hour. You're part of a cosmic adventure that's been going on for nearly 14 billion years, and you get to be conscious of it, to appreciate it, to feel wonder at it. That's what it means to be human on the pale blue dot, the only world we've ever known, and the most remarkable world we've ever imagined. As we've explored Earth's place in the cosmic hierarchy and contemplated the perspective that comes from seeing our world from vast distances, a profound question emerges. Just how special is our pale blue dot? Is Earth one example among billions of similar worlds scattered throughout the universe? Or are we something much rarer, perhaps even unique? Carl Sagan spent much of his career contemplating this question. His work on the search for extraterrestrial intelligence, his studies of planetary atmospheres, his involvement in designing messages for spacecraft leaving our solar system, all of these reflected his deep curiosity about whether we are alone. And what he discovered, both through his research and through decades of careful thought, was something both humbling and remarkable. While planets appear to be common in the universe, planets like Earth may be extraordinarily rare. Let's explore what makes a world capable of supporting complex life, and why our pale blue dot might be more special than we ever imagined. The basic requirements for life as we know it seem simple enough: liquid water, organic chemistry and an energy source. But when you look closely at what's required to maintain these conditions over the billions of years necessary for complex life to evolve, the list of necessary conditions becomes surprisingly long and specific. Earth orbits in what astronomers call the habitable zone around our Sun, not too hot, not too cold, but just right for liquid water to exist on the surface. This Goldilocks zone is narrower than you might think. Venus, just slightly closer to the Sun, experiences runaway greenhouse heating that makes its surface hot enough to melt lead. Mars, just a bit farther out, is so cold that any water on its surface freezes solid. But location is only the beginning. Earth's nearly circular orbit keeps us at a stable distance from the Sun throughout the year, preventing the dramatic temperature swings that highly elliptical orbits would cause. Our size is perfect, large enough to hold onto a substantial atmosphere and maintain geological activity, but not so large that we become a gas giant like Jupiter. Hidden beneath our feet, Earth's molten iron core generates a magnetic field that shields us from harmful solar radiation and cosmic rays. Without this invisible shield, our atmosphere would have been stripped away long ago, leaving our world as barren as Mars. And then there's our moon, unusually large relative to Earth, more like a companion planet than a typical satellite. The moon's gravitational influence stabilizes Earth's axial tilt, preventing the chaotic wobbling that would cause devastating climate swings. It also creates tides that may have been crucial for life's transition from ocean to land, creating those special intertidal zones where early organisms could adapt to both worlds. The moon's origin story is itself remarkable. The leading theory suggests it formed from debris when a Mars-sized object collided with the early Earth about 4.5 billion years ago. Think about that for a moment. A collision violent enough to melt both worlds, yet precisely calibrated to create a large moon without destroying Earth entirely. A cosmic accident that may have been essential for everything that followed. Even our location in the galaxy matters. We orbit a stable, long-lived star in a relatively quiet galactic neighborhood, far from the chaotic center where radiation levels would be lethal to complex life. Jupiter, our giant neighbor, acts as a kind of cosmic bodyguard, using its massive gravitational field to deflect many comets and asteroids that might otherwise impact Earth. The timing of Earth's formation was also fortuitous. We formed early enough in cosmic history that our Sun will remain stable for billions of years more, but late enough that previous generations of stars had already created and dispersed the heavy elements necessary for rocky planets and organic chemistry. And here's something Sagan found particularly fascinating. Earth's atmosphere contains oxygen, essential for complex life, but that oxygen was actually created by life itself through billions of years of photosynthesis. Earth's atmosphere supports complex life, but complex life helped create Earth's atmosphere. This kind of feedback loop, where life and environment shape each other over geological timescales, may be essential for long-term habitability, but it also makes suitable conditions much more difficult to arise in the first place. When we add up all these requirements, the right star, the right distance, the right size, the right moon, the right magnetic field, the right galactic location, the right timing and cosmic history, the probability of all these conditions occurring together begins to seem remarkably small. This has led some scientists to propose the rare Earth hypothesis, the idea that while simple life might be common in the universe, complex life requiring all these specific conditions might be extremely rare. Earth-like planets might be so uncommon that we could be alone in our galaxy, or even in the observable universe as far as complex life is concerned. But here's where things get interestingly complicated. We've only recently developed the technology to detect planets around other stars, and we're already finding that planetary systems are incredibly diverse. Some have giant planets orbiting extremely close to their stars. Others have multiple stars creating complex gravitational environments. Some planets are tidally locked, others have highly eccentric orbits. This diversity suggests that our solar system might indeed be unusual, but it also means we're still learning what kinds of planetary systems might support life. It's possible that life could find ways to survive and thrive under conditions we haven't considered, or that there are multiple pathways to habitability that we haven't yet discovered. The search for life beyond Earth has become one of the most active areas in astronomy. Projects like the Kepler Space Telescope and its successor, TESS, have discovered thousands of exoplanets orbiting other stars. Some appear to orbit in their star's habitable zone, though we don't yet know enough about their atmospheres or other properties to determine whether they could actually support life. Future missions will be able to analyze the atmospheres of nearby exoplanets, looking for chemical signatures that might indicate the presence of life. These searches might help us understand whether Earth is truly rare, or whether life has found ways to adapt to a wider range of conditions than we currently imagine possible. But even if we discover that Earth-like conditions are common in the universe, that wouldn't diminish Earth's preciousness to us. It would still be our home, the place where human consciousness evolved, the world that contains our entire cultural and biological heritage. And if we discover that Earth truly is rare, perhaps even unique, that would make it even more precious. It would mean we're not just living on a planet, but on the planet, possibly the only world in the universe where complex life has evolved, where consciousness has emerged, where beauty and love and art and science exist. From either perspective, Earth deserves our care and protection. Whether it's one example among many or a cosmic rarity beyond measure, it's still the only home we've ever known and the only place where we can be certain that life and consciousness are possible. The question of Earth's cosmic rarity also has profound implications for how we think about our future as a species. If Earth-like worlds are common, then perhaps life and intelligence are common too, and we might eventually make contact with other conscious beings who have evolved on other pale blue dots around other stars. But if Earth is truly rare, then we might be alone in the universe, or at least alone in our cosmic neighborhood. This would make us not just inhabitants of Earth, but custodians of something unimaginably precious. The only place in the known universe where matter has organized itself into patterns complex enough to contemplate the universe itself. Either possibility is profound, Either we're part of a universe teeming with life and consciousness, or we're the universe's only experiment in self-awareness. Either we'll eventually join a galactic community of intelligent beings, or we bear the sole responsibility for keeping consciousness alive in the cosmos. What we know for certain is that Earth is the only place where we've confirmed that complex life exists. It's the only world where we know consciousness has evolved. It's the only planet where beauty, love, art, music, and science flourish. It's the only place where beings can look up at the night sky and feel wonder at the cosmos. This makes Earth precious beyond any material measure. It's not valuable because of its gold or oil or rare minerals. It's valuable because it's the only known place where value itself can be experienced and appreciated. It's not important because it's large or central. It's important because it's the only known place where importance can be understood and contemplated. As you prepare for sleep tonight on our remarkable pale blue dot, you can rest in the knowledge that you're part of something extraordinary. Whether Earth is one among many or unique in the universe, you're participating in an amazing cosmic story. You're made of elements forged in the hearts of stars, organized into patterns that can experience wonder, beauty, and love. You're not just living on a planet. You're living on the planet where the universe has become conscious of itself, where matter has learned to contemplate its own existence, where atoms have evolved into beings capable of appreciating the cosmic story of which they're part. That's what makes our pale blue dot, rare or common, the most precious place we know in all the vastness of space and time. As our cosmic journey draws to a close tonight, let's take a moment to simply rest in the wonder of where we've travelled together, and more importantly, where we are right now. We've seen Earth through the eyes of astronauts who looked back from the moon and found themselves transformed. We've traced our cosmic address from local neighbourhood to the edge of the observable universe. We've explored how perspective itself can shift consciousness. And we've listened to Carl Sagan's meditation on a photograph that shows our entire world as a single pixel of light suspended in a sunbeam. And through it all, we've contemplated what makes this pale blue dot so precious, perhaps not despite its smallness, but because of it. But the most remarkable thing about tonight's journey isn't any single fact we've discovered. It's the simple recognition that you, right here, right now, are participating in something extraordinary. You're resting on a world that's dancing through the cosmos at speeds we can barely comprehend, part of a cosmic ballet that's been unfolding for nearly 14 billion years. And somehow, through chains of events so improbable they seem almost impossible, you get to be aware of it. The atoms that make up your body were forged in the nuclear furnaces of massive stars that lived and died billions of years before Earth even existed. The elements in your blood, your bones, your brain, they've travelled across vast distances of space and time to come together in the pattern that is uniquely you. You are quite literally made of stardust that has learned to contemplate the stars. But you're not just observing this cosmic story from the outside, you're participating in it. Every time you feel wonder at a sunset or awe at the night sky, you're part of the universe's ongoing attempt to understand itself. Every act of love, every moment of beauty, every insight into the nature of reality contributes to the remarkable phenomenon of consciousness that has emerged on our pale blue dot. The cosmic perspective we've explored tonight doesn't diminish the importance of your daily life. If anything, it enhances it. Your relationships, your work, your dreams and hopes and fears all unfold against this magnificent cosmic backdrop. You're not just living your individual life, you're participating in the universe, becoming aware of its own beauty and complexity. This perspective can be deeply comforting when life feels overwhelming. The problems that seem insurmountable from up close often appear more manageable when viewed from the cosmic perspective. The conflicts that divide us as humans seem less important than the simple fact that we're all fellow travellers on this remarkable journey through space and time. But this perspective also comes with responsibility. If Earth is indeed rare or unique, if consciousness is indeed precious and uncommon in the universe, then we have a duty to care for the conditions that make it possible. We're not just inhabitants of Earth, we're its stewards, perhaps the only conscious beings in our cosmic neighbourhood, capable of appreciating and protecting the pale blue dot that contains everything we've ever known or loved. This doesn't mean you need to solve all the world's problems single-handedly. That would be overwhelming from any perspective. But it does mean that every act of kindness, every effort to understand rather than judge, every attempt to care for our shared home contributes to something larger than yourself. You're part of the universe taking care of itself. Consciousness, nurturing the conditions that make consciousness possible. We are deeply connected, you and I and everyone else who calls this world home. The same atmosphere that you're breathing right now has been breathed by every human who ever lived. The water you drink has flowed through countless other bodies, evaporated into clouds, fallen as rain on distant continents, and cycled through the global system that connects all life on Earth. You share not just a planet, but a biosphere with every other living thing. The oxygen released by a tree on the other side of the world might find its way into your lungs. The carbon dioxide you exhale might eventually be absorbed by a plant thousands of miles away. At the most basic biological level, all life on Earth is interconnected, sharing the same resources, the same atmospheric chemistry, the same cosmic fate. From this vantage point, the things that seem to divide us, nationality, ethnicity, religion, ideology, are like lines drawn on the surface of our spinning world. They're real, and they matter for many practical purposes, but they're also temporary and changeable. Human constructions overlaid on the deeper reality of our shared existence on this small planet. What's permanent and unchangeable is our common origin in stellar nucleosynthesis, our common participation in the cosmic story, our common residence on the only known world where consciousness has emerged to contemplate the universe. These connections go deeper than any human differences and will outlast any human conflicts. As you prepare for sleep tonight, you can rest in the knowledge that you're part of something magnificent. You're not just going to sleep in your bed, in your room, in your city, in your country. You're going to sleep on a pale blue dot that's carrying you through the cosmic dark, through a universe filled with wonders we've barely begun to explore. Tomorrow, when you wake up, you'll wake up on the same remarkable world, under the same vast sky, part of the same cosmic story. The sun will rise, or rather, Earth will rotate to bring your location back into sunlight, and you'll have another day to participate in the ongoing adventure of consciousness in the cosmos. If you step outside tomorrow night and look up at the stars, remember that you're looking at your cosmic ancestry. The light reaching your eyes has travelled across vast distances to connect you with the universe beyond our pale blue dot. Some of those stars are younger than our sun, some are older. Some might have planets of their own. Some might even have their own pale blue dots where other conscious beings are looking back toward our corner of the galaxy. But even if we're alone in the universe, even if consciousness is the rarest phenomenon in all of cosmic history, you're still part of something wondrous beyond measure. You're the universe waking up to its own beauty, complexity, and meaning. Your matter organized in such a way that it can experience wonder, love, hope, and dreams. Carl Sagan spent his life helping us see this, helping us understand that we are a way for the cosmos to know itself, and in that knowing, in that awareness, lies both our cosmic significance and our cosmic responsibility. So, sleep peacefully tonight on our pale blue dot, knowing that you're exactly where you're supposed to be in the cosmic scheme of things. Rest well in the knowledge that consciousness itself is resting in you, that the universe is dreaming in your dreams, that the stars that made you are still shining in the night sky above. This is the Sleepy Astronomer, wishing you sweet dreams, fellow travellers on Spaceship Earth. Until we meet again, perhaps to explore how Carl brought the cosmos into our living rooms, or to understand his search for cosmic companions among the stars. Rest well on our beautiful, precious, irreplaceable pale blue dot, the only home we've ever known, and the most remarkable place we can imagine in all the vastness of space and time.